So we have seen how we can recover the whole Lie model from the HGM model. Let's take a look at how we can recover the whole Y one-factor model from a one-factor HGM model. So we have mentioned that if we were to have a particular form for the volatility term, we can recover the whole Y one-factor model. So what is the whole Y one-factor model? Now, recall that under the whole Y one-factor model, the price must take the price of zero coupon bond must take this particular form, which is the same form actually for whole Lie as well, except that A and B will take different expressions. Here, under whole Y, B is taking this particular form, and the log A must be taken this particular form as well. So let's see how we can recover that. Well, take a generic process for zero coupon bonds under risk neutral. So the drift is always this, and the vol term is obviously some v function here as a volatility times p dz. So the importance is here to determine what this v is. Okay, now if we under HJM set the volatility parameter in the HJM process as a constant multiplied by e to the power minus a times big T minus small t, then which means that this partial derivative of this thing here must be taken a negative of this thing here, right? As we mentioned earlier, there's a negative correlation, there's a negative sign there. So sigma e to the power minus a times t minus t. Okay, now we follow exactly the same approach from last time. We have to integrate over t and figure out that constant, well, figure out that function alpha t, alpha little t. So if we integrate based on this thing over t, big T, we have this v little t big T function here taking this particular form. So it's a simple integration here. And we then need to know what is this alpha little t. Again, we determine this through the boundary condition. And the boundary condition is obviously the volatility must be 0 when little t becomes big T. So then this thing must be 0 when little t is big T. So which means this alpha t when t is big T must be this thing here, right? So must be 1 over alpha sigma minus a t minus t. So therefore, it means that this part is 0, and then e to the power 0 is 0, so you have minus sigma over a. Therefore, you will put everything together with this being the alpha t expression. Now here isn't it really not a function of little t anymore. It's just a parameter sigma divided by another parameter a. And so you put them together, you have, this part minus this thing here. Just take the common factor here then you get 1 minus this thing here. Okay, now, so we figure out this volatility term for the zero coupon bond process. So let's plug it in. So if we have this, we then also given that if beta, oh sorry, if B is taking this form, which is actually from here, we will say that the process is this times sigma times this B times T here. So now if we change, under the HJM, if we have the volatility of the process taking this particular form, rather simple form here, we see that we have, exactly this vol term that has 1 minus this e to the power minus a times t minus t, which is exactly this b here. And so essentially you multiply this 1 over a inside the bracket. Okay, that will give you a b from here. So then you're only left with alpha, so minus alpha times b. Now recall that it's actually interesting here, in this case, this alpha t is not a function of little t, whereas in the whole Lie model, that this thing here, this alpha t is actually a function of little t. So here you actually have a simpler expression here. Now let's take a look at what the process is under the whole Y one factor model and see whether that process for zero coupon bond is exactly what we have derived here from the HJM model. Okay, so if you have the whole Y model, your price must be taken this particular form, and with the expression of A and B, and then your interest rate process is this, as we mentioned earlier last time, with a mean reversion here. Now, again, taking the same approach, we're gonna use Ito's lemma, and so if dr is this process, then dp must, under risk neutral, must be rp dt plus dp dr times sigma dz, right? So the question then is this partial derivative. So the partial derivative here, it take this under this form is really this minus bt from here. So this b here from here. Now, if b is this, because this is what we know, we have that from the expression of the whole Y model. B must take in this particular form. Then the price process for zero coupon bond under whole wide must be rp dt minus sigma times b times p dz, which is exactly this thing here. Or if you don't write p, you can just write out this particular expression, right, on both ones. So that they're essentially the same. So now we're demonstrated that we can specialize the volatility terms of HJM process, and depending on how we specialize that, whatever restriction we put it on, we can recover different short rate models that that we have seen earlier. Now we have used the whole Lie model and the whole Y model as two examples. In general, any short rate models that you have or anybody has derived can utilize exactly the same approach to demonstrate that if the HGM model is specialized in a certain way or is restricted in a certain way, we can recover that. The important thing obviously is to know what restriction to put on to recover that.